Okay, so now we are going to trace the execution of insertion sort and also merge sort for these two different lists. We start with the first one, which is the list that contains 6 elements. We will start with isort. Okay, so this is the list of elements. We just repeated the writing over here. Okay, so these are the 6 different elements. So we start with the second element. The second element we compare to the previous one. This is one comparison, and we will swap location, and we reach the beginning, so that will be it. And then we process the third element. It will have 2 comparison, compare against 93, compare against 85. So we'll write down the sorted portion of the list. For the first one, we see there's a 1 comparison. For the second step, second element, you can see that there are 2 comparisons. So for the third list, a third element in the list is going to be 69. So we just highlight the element that we are processing in each and every row. So 69 will compare to 93, will compare against 85, and then finally it will compare against 22, at which point it will conclude that it has identified an element as smaller, so it will stop. So you have 3 different comparison, and we write down the compare result, right, which is the insertion of 69 to be right after 22. Okay, so this is our currently sorted portion. Then we handle the fifth element. So 1 comparison, 2 comparison, 3 comparison. Again, we will terminate after we reach an element that's smaller. Okay, so now we are at the final element. So let's write down all the elements over here. The final element is 59. Okay, so we have 1 comparison, 2 comparison, 3 comparison, 4 comparison, 5 comparison. All right, so these are the all the comparison that we have. So in total, we have 1 plus 2 plus 3, 3. This is 9 plus 5. We have 14. Okay, so this is for the insertion sort. Numbers of comparison equals 14. Now on the right hand side, we can execute the merge sort. Again, remember, this is a bottom-up process. So we write single element at the lowest layer. Okay, and then gradually we will merge up. Okay, so 1 comparison each, right? So we just highlight the numbers of comparison needed for the merging of 2. This is a GS group size equals 1. We merge it to the case where your group size now equals to 2, right? And then they will be in order, right? 22, 69. We highlight. This is the sorted portion. 59, 73. Okay, so now we are going to merge these 2 into 1. The last one will be isolated. You cannot find another pair, so he will just wait for the next turn. Right, so in this case, we have 1, 22 goes up. This is the first comparison. And then 69 against 85, the second comparison. And then after that, this list, the second list become empty. Right, so we don't need further comparisons. The first list will just be inserted at the end. All right, so now we are ready for the final merge over here, right? This final merge. Again, the head element, 22 against 59, 22 goes up. This is number 1. And then 69 against 59. right? 59 goes up. This is number 2. 69 against 73. 69 goes up. This is number 3. And then 73 against 85. This 73 goes up. This is number 4, right? So again, after you have this 4 comparisons, 85 and 93 will go up, right? So this whole list is fully sorted. This is GS equals 4, right? We sum up all the individual comparisons. We have 1 plus 1 plus 1 plus 2 plus 4. We have 9. Okay, so to summarize, the merge sort numbers of comparison equals 9. All right, so now we're going to do the same, but with a slightly larger list. We repeat the same process. 24, this is the first element, don't need to do anything. But then we process 53, right? 53, you need one comparison, and then to confirm that nothing need to be done. And then we have 24, 56, we write 30. This is the element we are processing compared to this one, compared to this one. 2 comparisons. And then we write down, this is the fully sorted portion. And the next element that we handle will be 28. Comparison 1, comparison 2, comparison 3. 3 comparisons. Okay, so we write down again 24, 28, 30, 56. Right, this part is fully sorted. Then we write down the next element, 47. 1 comparison, 2 comparison, right? So we have encountered a smaller element, so we'll drop it and do the insertion. 24, 28, 30, 47, 56, and then we have 91. Okay, so now we process 91. Immediately it comes to a stop, right? So just one comparison, right? Just write it down. Okay, and then the next element, 60. 1, 2, 2 comparisons. You have encountered a smaller element, so you write it down. 56, 60, 91, and then we have one final element. 1, 2, 3, 4, 5. 5 comparisons. So you sum up everything over here. That will be the total numbers of comparison. This is 6, 8, 9, 11, 16, right? 16 is the final count, right? So for I sort, we have 16 comparisons. Okay, so we do the same. So this is left-hand side, this is I sort. On the right-hand side, we follow the order. We do a bottom-up merge sort. 30, 28, 47, 91, 60, 36. Right? 1, 2, 3, 4, 5, 6, 7, 8. Right? GS equals 1. Right? The first merge, for each and every group, you have exactly one comparison. Right? And then we have a group, a pair of 2, which are fully sorted. 28, 30, 47, 91, 36, 60, right? And then we merge to a group of 4. right? So this part, we need to count numbers of comparisons carefully. 24 against 28. This is the first comparison. 24 go up. 56 against 28. This is comparison number 2. 56 against 30. This is comparison number 3. And then 56 go up. We saw comparison. So you have 3 comparisons over here. On the right hand side here, we do the same. 36 against 47. 36 go up. 47 against 60. 47 go up. This is number 2. And then 60 against 91. 60 go up, right? So 3 comparisons. And then the last one can go up. We saw comparison. Right, finally, this is the final merge. You go to the case where your size equals 8. The first element, 24 against 36. 24 go up. This is number 1. 28 against 36. 28 go up. This is number 2. 30 against 36. 30 go up. This is number 3. 36 against 56. 36 go up. This is number 4. 47 against 56. 47 go up. This is number 5. And finally, 56 against 60. 56 go up, right? So this is number 6. So now after that, after 56 go up, the first list become empty, right? So the remaining element in list number 2 will simply be inserted without comparison. So you have 6 different comparisons. So in total, if you look at the M sort, numbers of comparison is you have 4, right, at the lowest level, plus 3 and 3, that's 6, and then you have 6, right? So in total, it is actually also 16, right? Which in this case just so happen to be the same as the insertion sort, right? So one example to demonstrate that although complexity wise, in the worst case, M sort should be better, but there will be cases where, I mean, 2 sorting algorithm may produce exactly the same result, or you can actually have some cases where I sort can have fewer comparison. That's also possible, right? You can think about how you can craft this kind of case.